Hey, what's going on, guys? This is another Mr. Sanchez with another lesson coming at you with a lesson 4, geometry. I forgot to write that here. Geometry. We are doing lesson 22-3 using trig ratios. Our learning target today is to use trigonometric ratios to find the lengths in unknown side lengths in right triangles. So we're going to be using sine, cosine, and tangent. And I have one example for when to use each. It doesn't matter which side length is missing. I'm just showing you um, how to solve for the missing piece, right? So we have here example 1. We're just going to jump straight into it, and then I'll just tell you my thought process everywhere. Okay, so we have this first example, and it's always solve for x, right? Solve for x. All right. So one thing that I want to tell you guys is that before we even solve for x, just so you know, sine, cosine, and tangent, they. So if you ever get sine of 20 degrees, that's already a number. This is like, we can call this number, if I plug into a calculator, actually put sine 20. This is not like a function. It's just 0.34, right? So it's just that number. So, but so we know that much. Sine 20 is a number, but we also know that sine of 20 is also going to be whatever the opposite over the hypotenuse is. All right. So when we have this information in a triangle, we'll be able to solve for x. And I'll explain what I mean in the beginning. So before we even begin, let's look at this problem like we don't know what we're doing. It says solve for x. We have x here. What is x? X is the opposite side of our given angle, right? So we have our opposite, and then they also gave us the hypotenuse. And really and they gave us this angle 20. Really, that's all we need. We don't even care about the adjacent side because that's all we need to solve for x. So to solve for x, what we got to do is set up the equation, right? So we know sine 20 is a number. Like I just said earlier, it's some number. But that number is going to be equal to, because it's sine, it's still going to be equal to opposite over hypotenuse. All right, and what's the opposite in this case? The opposite here is going to be x, and my hypotenuse is 15. All right, so sine of 20 is going to be equal to this, okay? And I can move this up over here. All right, so let's move this up over here so we can finish solving this. We have sine of 20 equal to x over 15. To solve for now, all we have to do is use algebra to solve for x. So we're going to multiply both sides by 15 times 15, and you're going to get x is equal to 15 times sine of 20. Now, if this was our test, we just leave our answer like that. You don't really have to go any forward, especially if you don't have a calculator. But because we do have a calculator, we're going to just type that straight in. 15 times sine of 20. And if we do this right, you should get that this is equal to approximately 5.13. All right, and that's going to be our answer. And the reason we knew to use sine is because if you look here, they gave us the opposite and the hypotenuse. Opposite and hypotenuse. What uses opposite and hypotenuse? If you look over here, opposite is and hypotenuse, that corresponds to sine. So that's how we knew which one to use. Okay. And so we're gonna keep referring to this little chart to determine what trig ratio we're going to use to solve for our value. So let's go to number 2. All right, let's go to number 2. So we have problem number 2, and that says we have an angle 10. All right, we're going to use that as our reference angle, and we're going to have the hypotenuse, which is our unknown. Right, we know it's the hypotenuse because it's across from the right right angle, and then this right here is going to be our adjacent leg because it's right next to our angle, right? So what uses hypotenuse and adjacent? Let's look over here. Which one uses hypotenuse and adjacent? That's going to be cosine. That's adjacent and hypotenuse, all right? So we know we're going to be using cosine of 10, right? And that's going to be equal to the adjacent over hypotenuse. Okay, and you're probably thinking, okay, so let's continue this over here. So that means that our cosine of 10 is going to be equal to our adjacent side, which is 12, divided by our hypotenuse, which is y, right? And now we gotta solve for y. And we use algebra. Um, the reason the y ends up on the bottom here, whereas the other one it was on the top, is just because we're solving for the hypotenuse length. Usually when you solve for the hypotenuse, the y ends up on the bottom. And if you're looking for the adjacent or the opposite side, you're gonna look for, it's gonna be on top, unless you're using tangent, in which case it's a totally different story. But it's still the same process overall. We're going to multiply both sides by y, and you're gonna get y times cosine of 10 is equal to 12. And then all you need is the last step, which is to divide both sides by cosine of 10, because we know that's a number. All right, we're gonna divide by cosine of 10. That's going to go away, and we're going to get y is equal to 12 divided by the cosine of 10. Now, if we use our calculator, we're gonna realize that we're going to see that this is equal to approximately 12 divided by cosine 10. And this is going to be equal to approximately 12.1819. Okay, and that's going to be our answer. Once again, we knew we had to use cosine because we were given the adjacent side and the hypotenuse of our angle. And when you have adjacent and hypotenuse, you want to use the cosine. Okay, let's go to our final problem. Okay, our final example, we have this nice triangle over here, right? So this time they gave us the angle 45 degrees. And let's see what else they gave us. They gave us the opposite side, right? And they also gave us the adjacent side this time. Notice how this is the hypotenuse and we're not even looking for the hypotenuse, we're looking for x. All right, so what uses adjacent and hypotenuse? I mean, the opposite and the adjacent. Well, that's going to be tangent for this problem because we're dealing with the opposite side and the adjacent side. So if we go to problem number 3, we know that we're going to have that the tangent of 45 is going to be equal to the opposite over adjacent, right? Which we all know we can rewrite as the tangent of 45 is equal to, we're looking for opposite, so that's 34 over adjacent, which is x. Once again, this is on the bottom because of the way our fraction worked out. It's okay. Sometimes you'll get x on top, sometimes you'll get x on the bottom. You're always going to start out by canceling out the fraction, okay? So we're going to get rid of the x from the bottom, and that's going to cancel out, and we're going to have x tangent 45 equal to 34. And then when you divide both sides by tangent of 45, you're going to get the following answer. So if you do this, me, because I've been doing this math a lot, I know that tangent of 45 is 1. So if you actually just type this into your calculator, 34 divided by tangent of 45, you're going to get 34 because tangent of 45 is 1. So you're going to get this is equal to exactly 34. Okay. And that's it. That's how you solve these problems. It just depends on what side, what you're given and what you're looking for, right? So we're looking for the adjacent side and we're given the opposite. That means we're going to look for tangent. We're going to use tangent. If you're given adjacent and hypotenuse, you know that involves cosine. And if it involves the opposite and the hypotenuse, that is sine. And that's basically how you solve these problems. It shouldn't be too hard. You can use this notes during the test. I hope you don't. I hope you study on your own before the test, but no one can really determine that except for you. All right. Other than that, have a great day. I'll see you all on Thursday. Bye-bye.